Okay, so we'll be doing polymerization tonight, and I just felt it was necessary because a lot of kids are having problems um, just polymerizing anything that's given on 60 papers, and it's really pretty easy. So here we go. Here I have a alkene. Anything with a double bond between it here is called an alkene, and uh, basically X would represent anything from chlorine, methyl, benzene, amine, hydroxyl group, etc. It could represent anything. I put on I made X hydrogen, right? So doing that, if we polarize the above, we'll get CH, CCH. I put 3 units. This is 3 units, and you can see basically it's repeating itself throughout. See, it's the same thing. It's the same 2 carbons like up here. That's repeating itself throughout 2 carbons and 2 carbons again. Okay. So polymerization is pretty simple. Whenever you want to polymerize a monomer, units having a double bond, it goes through addition polymerization. When this occurs, just take into account the 4 other groups surrounding the 2 carbons that are bonded by the double bond. And here I have an example, A, B, C, D. So for example, suppose you had a molecule looking like this, something weird, something that CXC would bring just to quite frankly piss you off, right? What we would do, I will condense everything. First, I will take into account everything around the 2 C's that share the double bond. So we must have 4 spokes. We have one, two, three, and the fourth one. I would circle all of them, right? Circle, this is one, this is two, and this is three, and this is four. So I have my 4 groups, right? Pretty cool. And then I will condense it. As you see on this page, it's condensed, right? Making my ability to polymerize much easier. I wouldn't have to think about all those weird bonds that was going on a while ago. So if I were to polymerize this and give it 3 units, produce 3 units of it, of course you have your double bond bursting, cutting and opening it to make a single bond, and you would have CH3, right? And then you would have your OH, and then again you would have your we have CH3 here. Forgive me for writing on a slant. Pretty much can't help it right now. And of course, it'll just repeat itself. Obviously you would have 6 C's in the end, and you have each of the groups being repeated, going across, right? You have your OH, and you'll have your OH, right? You have your CH3 and your CH3. And of course, if you already wrote it down without me saying it, you would have a CH3 here and your OH here and your CH3 here. And it's always important to have it in order, just like how it was presented to you, because you have your OH here and your OH here. It's not the same thing if you put your OH and your OH on top and your CH3 and your CH3. It's not the same thing. So refrain from writing it incorrectly because you could be penalized on your exam. Make sure you have your repeating your infinity dots going on, and don't forget to put your square brackets and to stand for infinite amount. Here we have another type of polymerization, which is called condensation polymerization. It usually occurs between an acid, such as carboxylic acid, and an alcohol. So here this, you would have this reacting, you have this reacting with this, and all of this would go, and only the oxygen from the alcohol group would be left. So this is your alcohol because you have your hydroxyl group here, and this is your acid, your carboxylic acid, because you have your carboxyl group here. And what you would basically find would be this. Um, the same thing. You have your 3 C's, your 3 C's, You hear those stupid dogs again? And then of course you would have your oxygen from your alcohol side. Sometimes I don't put my H's in for rushing purposes, but you should always put your H's in. Otherwise, then what are you trying to tell the examiner, that you're something so great you don't need to put your H's in? They'll just make you know how great you are by penalizing you on the exam. So make sure you always put your H's in, and not that hard. Once you know what you're doing, you're gonna pretty much pass the exam, but don't forget to cover all bases. And this is known as you're gonna name your alcoholic site first. And since you have two carbons, it will be ethyl, ethyl. You have three propanoids. You always name the alcoholic site first and put the ill behind it. So you just had one carbon, you say methyl propanoid. So yeah, that's one. That's between a can. The next one that goes to condensation is the amine, between an amine and a carboxyl group. So this one, what will happen? You will have water being formed like this, right? And your product will be this right here. I might have to change my nibs on the pen. It's acting up. And this is called a peptide bond. Right, the peptide bond formed between there is called peptide. Please note that my H's are actually big H's. I am just, this nib on the pen is acting up. Either the pen or my pad has dirt on it. I don't know. Pretty grainy. My dog probably sat on it. Naughty dog. But yeah, that's pretty much it. And just to let you know, what's the peptide bond consists of these four atoms together to form that wonderful peptide bond. And there you have it, polymerization made easy. Please subscribe, make sure you subscribe, and make sure you comment below. Subscribe and comment below. It'll be appreciated. One love, good night.